if we need to find the velocity between two close times. For example, look at page number 8. If I move from point A to point B, for example, if I ask you to find the average velocity, you just need delta x from here to here, and you need delta t between these two far points. But there is another thing different, which is instantaneous velocity. It is the velocity at each point. Assume yourself after, for example, delta t is equal to 0, 0, 0, 0. This is the decimal point. 1 second. This is a small period of time. So you are here. By the way, this is the velocity or the speed that given in the scale of your car. It gives you the speed now, which is the instantaneous velocity. In this case, delta is very big. We need another thing is small. In math, we need to find the limit or to use the limit of delta, which is d. In this case, it will be equal to dt. So d, it is the same as delta, but it is small. And delta x, in this case, it is very small. It will be dx. Then the velocity. The average velocity, or is equal to, sometimes they write it like this. It is equal to delta d, delta x in one dimension over delta t. But v instantaneous, it is equal to the limit of v average at delta t goes to 0 or goes to dt. It will be equal to dx over dt. Simply, it is the same thing. Okay. The next part of page number 8, I cancel it. This is page number 8 because it is a differentiation. It is a calculus. We don't need it. The next part. Now we need to use the graph again. You have many pages have the same graph. Just these are for you to use them many times to solve what you need to solve. Let me try to draw it here. Be careful of this. You can use the graph in the lab for the acceleration for any future question. Okay. I have the page. Okay. Okay. We have the position here, which is x in meters. We have the time in seconds. I ask you to find the average velocity and the instantaneous velocity. When I told you I need the average velocity, then in your mind, the average velocity, it is between two far points. This is the time. The position. This is the position graph. The instantaneous velocity, it is at small period of time. Now, what about this graph? How can we understand this graph? Okay, this graph, it is here 2. Here it is almost 2.2. Here it is a 3 almost. Here it is 5. This is 6. Okay, and so on. This is 4. Here is 1. How can we understand this graph? You will see 1 or 2 of them in the exam or more. Now, assume yourself here and your friend is walking on the ground. You both start with x equals 0 and t equals 0. Then your friend start going away from you to reach this point, which is 6, because this is 10. Then after 2.2 seconds, he starts coming back. Okay, to reach this point at 0, 0, at time t equal 3.1 or maybe. Then he going far away from you, then coming back, then going away in the opposite direction. He is behind you now, there. To reach the farthest point at t equal 5 almost, which is at minus 30.8 meters. You can read that from the graph. He is away from you more than 30 meters behind in the negative direction with respect to you. Because our positive now to this direction, our negative to this direction. Then he come back to this point, to 0, after 6 seconds from the initial point. Then he continue going away from to the positive direction. All the information can be read from the graph. Now, what if I need, I will solve just one from here and one from here. The average velocity between 0 and 5 seconds. This is the 5 seconds. This is T0. So this is my initial and final point. I don't know about the colors, but I think they all will be white. So I have this point and this point. I need the average velocity. So I need the slope between these 2 points. I don't care about the positive velocity, the negative velocity, and so on. I just need the average velocity between these 2 points. There are a lot of information will be missed because the average velocity is between 2 far points. Okay? I will solve it here. The first one, I need the average or average between 0 and 5 seconds. This is in page 9. It is delta x. Delta x, it is here, which is negative 30.8 minus 0, right? This is 0, this is minus. I can name it. This is 0.1, this is 0.2. Any question online? I'll open the chat. I'm sorry, I see. Can anyone hear him? I asked in the beginning, can you hear me?
Yes.
Yes.
Thank you. Thank you for the question. Okay. The time, T2 minus T1. T2 is 5. T1 is 0. It's simple. You can do it. I will remove these things. It is negative 30.8 minus 0 over 5. It will be negative something. This is the calculator. And some of the important things, if I solve sine theta or tan theta, when theta is in radian system in my calculator, the answer will be wrong. You need it to be degree. We will talk about this later. And the first quiz, you have 2 times 2 attempts to you can solve it 2 times, and the highest grade will be counted. Be careful about this. You can do it again. This is just for the first quiz, and here the answer will be negative 30.8 over 5 will be negative 6.16. meters per second. It is negative. Some of you will tell me we have positive velocity in this period. We have negative here. So the average velocity will give you just an information about these 2 points. For example, if I go from here to Basel, sometimes I will stop with my car. Sometimes I will be fast, slow. I will return, come back for something. But the average velocity will be just one number for 2 points. Now, if I need to find the instantaneous velocity at 2.25 at this point, at the top, in math, if you need to find the slope of a line, if I need to find the instantaneous velocity, I need just to find the slope of that line passing from this point. In this case, I have 2 points. Then I can find the slope of 2 points. The line passing between them. But in this case, I have just 1 point. In this case, I can easily draw a tangential line. It is not like this, not like this. I need to choose the most suitable one. Because I know that the line is this. It is horizontal line. Okay? If I need to choose the line at the point, this point, at t equals 6 here, I can choose the tangential line like this. Then calculate or find the slope of that line. That's it. Okay, for this line, I need to find the slope of that line to choose 2 points. For example, this point and this point at t equals 3 and t equals 1. Then I need to find the slope. So the velocity. Now I have a small period here. A small window at this point. This is an instantaneous velocity at that time. It is a v instantaneous at t equal to how much? 2.25 seconds. It is delta x. Okay, delta x. How much is it? Yes, at the top here, it is 6. It is 6 minus 6. So I need to choose the 2 points. It is at t equal 3 and t equal 1. So it is 3 minus 1. It is my line. I can choose any points on it. So it is equal to 0 meter per second because 6 minus 6. You know that the horizontal line has a 0 slope. Okay? What if I need to choose the at time equal? Yes, I have it. At t equals 6 here. I need v instantaneous at t equals 6 seconds. Okay, I have my line. I just draw it. I need to choose 2 points. I can choose this one, which is at 6, and also I can choose this one at 5. Also, I can choose this one. So I will choose this point and this point. Maybe on the paper sheet, you will be better than me in drawing the line there on the board. I'll draw one here to be just close as possible. It will be almost. It will be at 6.6. The crossing line, the intersect line here. Minus. Oh, now I'm talking here about delta y. This is delta t. 6.6 minus 6. because I'm talking about this point, which is almost 6.6, and this point, which is at 6. What about this is delta t in the denominator? What about these 2 points? This point, which is T2, 0, minus at t equals 6 from the graph, it is, can you tell me it is 15? It is negative 15. Be careful, it is negative. So I have it negative 0, negative, negative, it's positive 15 over this minus this over 0.6, which is equal to 25 meters per second. It is positive. The line is going up. This is the instantaneous velocity at that point.